The first Metroidvania game that I ever made was for a month-long game jam, and it was a nightmare to create. I didn't know how to handle object persistence. I couldn't figure out how to handle having multiple doors in each scene and how do you know which door to spawn the player back to. And my scene transitions were really jerky and everything was just really unpolished because I didn't really know what I was doing. And to test the game, I literally had to play the game from the beginning every single time, just because honestly I didn't know how to do it any other way at that time. This is an experimental video. I have never made a video quite like this one before where there is so much stuff crammed right into one tutorial before, but essentially this is a video that I really could have used a few years ago. And we're going to go through all kinds of things in this video. We're going to handle having multiple doors in each scene. We're going to make an editor script so that we can just drag in scene references into a field. No more typing in string names for scenes. We're going to make a clean scene transition with a nice fade in and fade out. And I'll show you how I currently handle all persistent data in my games. Ready? Let's go. So here's our current scene, just a simple room with 2 doors, and I've got 2 other simple scenes that we'll transition to from those doors. And I'm calling this main scene Dungeon Level 1, Room 1. Doesn't really matter what you call it. I try to take a common sense approach with naming conventions, but if you have a genre with a lot of scenes, like a Metroidvania for example, you'll want to name it in a way that makes sense for your game. So how we're going to set this up is this door will take us to Dungeon Level 1, Room 2, and this one is going to take us to Dungeon Level 1, Room 3. It's also worth noting I've already gone ahead and added all 3 scenes to my build index, which you'll need to do before you can load a new scene during runtime. And we're just going to handle this whole thing one issue at a time. So first, let's start with the doors. So I'm using the new input system, and we're going to enter the door when we press the interact button. I have a manager's object here, and on that I have an input manager with a user input script which I set up, and a player input script which comes with the input system. Plug in your input action here and you're good to go. And I'll show you the code for my input really quick so you can copy it if you like the setup. So I'll use the interact as the example here. You can see we grab a reference to a public static player input in the awake function. That will allow us to reference the action from our asset over here and assign it to an input action variable here. Then you can just use a public static bool and in the update function just say was interact pressed is equal to the input action dot was pressed this frame. Nice and clean and simple. They're static variables, so you don't even need a reference to this script when you call it. You can just check for input from anywhere by just saying if user input dot was interact pressed. It's awesome. So that's how we've got that set up. Now, since we're using an interact button, we should set up an interact system in an efficient way. And we could make one door script and put all of the functionality into that one script, but maybe in our game, we're going to have chests and NPCs and switches and other things in the game that you want to interact with. So we'll use an interface and inheritance combo to pull this off instead. And if you don't know what that means, it's going to make sense really soon. So first, let's set up an interface script and call it iInteractable. This is not going to sit on a game object, so it's not a mono behavior, and it's not a class, it's an interface. Let's set up a variable for our player with a public getter and setter, and a bool can interact, and give it a public getter and setter. And also a public method called interact. Now, we don't need to say these are public because everything in an interface is public by default, and this is all we need for now. So let's go ahead and create a new script called trigger interact base. And I'm calling it that because this will be our base class for anything in the game that gets fired based on whether our player is inside a trigger collider or not. And let's add our interface to this, which will force us to implement the interface. And you can do that fast by right-clicking and clicking on Quick Actions and Refactoring and implement the interface. Now you can see it's added the bool in our method, and let's get rid of all this default code here. So in this class, because this is a base class, we aren't actually going to do anything with this function. We're going to leave it blank. And so that we can override it later on in a different script, we're going to make it a virtual method. Now in our start method, let's actually find a reference to the player. And if you do this, make sure that we actually tag the player as player. And in our update function, we're going to say if we can interact and the interact button was pressed, then we're going to interact, which again doesn't do anything just yet. And to tell whether we can interact or not, we'll need an onTriggerEnter2D and an onTriggerExit2D. We'll say if the object we collided with is the player, then we can interact here, and if we leave the collider, then we can't. So now we actually want to plug in the door functionality. Create a new script called door trigger interaction and make it inherit from trigger interaction base. And let's create an override for interact. And here is where we'll actually fade out, load the new scene, and fade back in and all that good stuff. So Unity doesn't have a built-in way of referencing a scene in the inspector, and I did some digging into this, but eventually I did stumble across a solution posted from Glitchers here, and I'm going to post a link to this article in the description. But how it works is we create an editor script, and we're going to basically make that functionality ourselves. I'm going to go through this script fast because editor scripting is outside the scope of what I want to cover with this video, but I do have a different video that walks you through the basics of editor scripting right here. If you want to check that out, it might help you understand this just a little bit better. But we're going to set up a class called SceneField, which is what we'll use as our type when we want to plug this into the inspector, and it's going to grab the scene name from that. Then we need to set up the property drawer for that, and this is all going to happen inside the onGUI method. We'll begin and end the property. We're going to grab a reference to our scene asset and scene name from up above. We're going to set the position based on our label. And if our scene asset isn't null, then we'll set up an object field of type scene asset. And if the scene asset isn't null, then we'll set the scene name string to be the value of the scene asset's string name. Okay? So all of that was so that we could go to the door trigger interaction and say, and we'll serialize it so it shows up in the inspector, private scene field scene to load. Now you can see once we add the door trigger interaction script to our door, we now have a field that we can drag scenes into. And what I really love about this method over using a string is you might not know your scene naming convention just yet. Maybe you're early on in your development. And so at some point down the road, you might end up renaming all of your scenes. And with string references, you're going to have to go through and re-enter everything here. And that's a giant pain. But with this, you rename a scene, it's going to update the reference automatically. So this can save you a lot of time and headaches. Now, we're also going to need to know two pieces of information when we enter a door. Which door is this within the current scene in case we want to spawn to this door from another scene, right? And maybe you have more than 4 doors, and if so, you can just add as many as you need here. And second, which door in the new scene that we're going to load into do we want to spawn at? And this is completely optional, but to make that just a little bit easier and less confusing, I just added a little script that displays the current door number in the scene when you select the door. And if you want that, here's the script for it. And make sure you put this script inside a folder called editor. But again, this is totally optional. And you can see it works like a gizmo because you can turn the text off by turning off the gizmos here. Now we need to handle the functionality of actually changing scenes and all that good stuff. So let's, under managers here, create a new game object called scene swap manager and create a new script with the same name and attach it and open it up. First, make it a singleton. We're only ever going to need one of these, and we're not going to do the whole don't destroy on load thing yet. We're going to handle that a little bit later on. We're going to need the scene management namespace as well as a variable to hold which door we want to spawn at. So what we're going to want to do here is a coroutine that takes in a scene field and a door to spawn at, and we'll set the default to none so that we don't have to enter a door spawn number if we don't want to, which just means that we could use this to change scenes for reasons other than the player entered a door. Now, first we want to start fading to black and then yield return null while is fading out is true. And then we can assign our door to spawn to and then load our new scene. So we'll handle the fade stuff in just a moment. But first, let's create a static void called swap scene from door use. That takes in the same arguments as our coroutine because we're going to call our coroutine from inside this function. And you'll notice that because this is a static function, we can't just call start coroutine because we need an instance of this class first. So we can say instance.start coroutine, and you'll need another instance when we call the coroutine here as well. But since it's static, we don't need a reference to the script. We can just go right to our door trigger interaction and say sceneSwapManager.swap scene from door use. Plug in the scene to load that we plug in for the door in the inspector, and which door we want to spawn to, which is also from the inspector. And that's it. So we are finally done with this door script here. Now the fade functionality is actually really easy. So let's set that up and then finish up the scene swap manager. So back in our hierarchy, let's set up the UI elements that we'll need to actually cover the screen in black or whatever color we want to use for our fade. So we're going to create a new canvas and we're going to set it to scale with screen size at 1920 by 1080. And as a child, we're going to add a UI panel, which we can scale up just a tad to make sure that it covers the whole screen. And to get rid of this compiler error, let's just quickly add a yield return null to this coroutine. Now let's create a new script called SceneFadeManager, and we're going to attach it to the canvas and open it up. And we're going to make this a singleton as well. And we're going to want a few variables, what images we are referencing, our fade out speed, our fade in speed, our start color for the fade, and some public bools so that we know when we're fading in and when we're fading out. And in our awake, let's start our fade out start colors alpha to be 0. Otherwise, this is not going to work properly. And in update, this is where we're going to handle all the actual fading. We're going to say if we're fading out and if the alpha is less than full, which it should be because we set it to 0 in the awake function, then we'll increase the alpha by time.delta multiplied by our fade out speed. And then make our fade out image color match our fade out start color. And this shouldn't be capitalized. Let's fix that. And if the alpha is not less than full, then we are done fading out. Now we'll handle fading in. So for fading in, if the alpha of our fade out image is greater than 0, then we'll reduce the alpha by time.delta multiplied by our fade in speed. And again, make sure the panel's color matches the start color since that's what we're adjusting here. And if it's not greater than 0, then we're done fading in. So the two methods we'll actually call to start this fading process is very simple. We're going to make start fade out, which will apply the start color to the panel cover and then say, yes, we're fading out. Then we want start fade in, which is the same. Make the panel color equal to the fade out start color and say, yes, we are fading in. Let's also make sure that this only gets called when our alpha is totally full. Okay. So we'll assign our panel here, and I'm going to choose a nice dark gray. So that's done. Now we can go back to our scene swap manager and implement the fade. So in our coroutine, we can call the start fade out method. And while it's fading out, yield return null. Then it's going to do all of this stuff. So let's test. First, let's make sure all our door stuff is set up correctly. So in this scene, this is door 1, and I'm also going to make it spawn to door 1 in our new scene. This is door 2 in this current scene, and it's going to also spawn to door 1 in the other scene because both our other scenes only have one door. Now in this new scene, we're going to make sure that this is labeled as door number 1, and it's going to go back to door number 2 in our main scene. And in this last scene here, we're going to make sure that we label this as door 1 for this scene, and it's also going to go back to door number 1 from our main scene. I hope that makes sense. So let's go back here and play. Currently, we should be able to go to a door and it fades to black and then it loads a new scene. But this isn't really how I want any of this to work. What I'd like is to have persistence with my objects. And what I mean is right now, back in our main scene, we have all this great stuff. We have managers, they handle our input and our scene management and our fade in. We have this panel set up. But right now, what happens when we load a new scene is all of this stuff gets destroyed and then a new scene gets loaded in. I don't want this stuff to get destroyed. I have several things that I want to persist in every single scene in the game. So what I'm going to do is create a persist objects game object and drag our managers and our canvas and our camera and our player and make all of them children of this persist objects game object. And for now, temporarily, what we're going to do is create a simple little script called persistence. And we're going to make it a singleton and call don't destroy on load. What that will do is when you hit play, this object as well as all of its child objects will be put under this don't destroy on load category. And as the name suggests, these are obviously not going to be destroyed when you load a new scene. They're going to persist. They're going to stay there. So now if we go through a door, it actually seems kind of like it made things worse, right? The screen stays black. We have 2 audio listeners, etc., etc. But this is actually really good. The screen is staying black because our panel persisted across scenes. So we know it's not being destroyed now. So what we want to do now is when a new scene is loaded, we want to call the fade in method. And to do that, we need to know when exactly a scene has been loaded. Luckily, there is a delegate already set up that allows us to do that very easily. So down here, let's set up a method called onSceneLoaded and pass in a scene and a load scene mode. And we'll need to add an onEnable and onDisable method so that we can subscribe that method to the sceneManager.sceneLoaded delegate. And we're going to add it here and subtract it here. So what that means is every single time a scene is loaded, this method is going to get called. And that also includes when we first run the game as well. So we need to be able to tell when we're loading from a door. So let's set up a static bool called load from door. And it needs to be static so that we can actually call it within this static method here. And let's set it to be true here. And so now what we're going to say is, okay, as soon as the scene is loaded, we'll start the fade in. And if we're loading from a door, then we need to handle warping the player to the correct location based on the door that we're entering, and then set this back to false. So let's test again. And this time, at least the fade out and fade in should complete properly. There you go. Now let's set up this door functionality, and to do it right, we'll need to have a reference to the player's collider, and the door's collider, as well as a private vector3, which will hold a reference to where we're actually warping to. So we're going to initialize the player and player's collider reference in awake. Now we're going to set up a method called findDoor, which takes in a door to spawn at enum. First, we'll find all objects containing a door trigger interaction script and go through each of them one by one. And if that door's position is equal to the door we want to spawn to, then we'll grab a reference to that door's collider. Calculate a spawn position for the player, and then return, which is going to cancel out of the for loop. Now we just need a calculate spawn position method. I want the player to spawn right on the ground, otherwise it just looks really amateurish. So let's get the player's collider height. And set the player spawn position to be the door's transform minus the player's collider height. And let's call that right here. So now back up here, whenever we load a scene, if it's been loaded due to a door, we'll find the door and send our player there. Let's test. Now, depending on the setup of your scenes, you might be having problems like me right now. So because these are now being brought across all scenes, if there are duplicates of any of them, like the camera, for instance, it's going to give us an error. It's saying we have 2 audio listeners in the scene because we actually do. We have one here and we have another one over here. So, okay, no problem. Let's make sure that none of this stuff is duplicated in any scene. No extra player, no extra camera, no extra managers, etc., etc. So let's remove all of that stuff from our scenes. But this kind of sucks because now my camera is gone. And if I want to see anything in the game view while I'm working on this scene, I would need to add the camera back in. So what we ultimately want is something that works nicely with builds, obviously, as well as something easy for working in the scene view as well. So we want something simple. And I got a little script from Tarodev, and I'll include a link to that video where I got it from in the description, where he goes over this in a bit more detail. But really, we're just going to drag this prefab into a folder called resources. And what this script does is we'll make sure to run it before the scene has actually loaded. And we'll say don't destroy on load and instantiate a copy of our persist objects from within the resources folder. So this is going to instantiate a copy of this in, and it's going to call don't destroy on load on it. And I tend to forget how things like this work after I've been working on a project for a long time, so I like to add a little debug.log statement that just reminds me where this object is actually being spawned in from so that I don't get confused later on. Now we can remove the persist script here since we no longer need it, and we can delete this out and press play, and there we go, it loads in all by itself. So now we're error free, we have persistent data, and it's all handled automatically. And what's really great about this is if you need something new to be persistent across all scenes, all you got to do is just add it to this object here. Now, this obviously isn't going to scale well if you need hundreds upon hundreds of things to be persistent, but for the scope of my projects, currently, this is how I handle things in almost all of my projects. Now, you certainly do not have to include your player or your camera in here. You could have a separate system that handles those things entirely. Really, it depends on your project and just how you like working, but I find this way to be very simple. If you need your game view camera in here while you're working in the scene, just drag in that prefab, do your changes, and then delete that out before you hit play again. Now, for just a little finishing touch, you'll notice that when we go through a door, we can still move during the fade out and fade in, which just seems a little bit wrong to me. So in my user input script, I'm going to create two functions that I can easily call by making them static, and one is going to disable the current action map, and one will enable it. So what I'm going to do is say, right when we start fading the scene out, let's take the player's control away. And I don't want to give it back till the fade in is done. So let's create a little coroutine that says while is fading in is true, do nothing and wait for the next frame. And when that's no longer the case, activate the player controls. And we'll call that right here. Let's test. And now if you're finding that you have to release the move button and press it again to get this to work properly, go to your movement and enable the initial state checkbox here, which will fix that problem for you. And there you go. This is how I handle doors, scene transitions, and object persistence in my Metroidvania game. And if you want to poke around in here a little bit more, my patrons get access to every tutorial via a GitHub repository. So if you're interested in that, then head on over to Patreon. Like the video if you liked. This one is a fair bit longer and more in-depth than what I usually do in my tutorials. So if you want to see more like this, then be sure to like the video and comment so that this gets shared with more people. Bye. I want to give a very special thank you to all of our Hall of Fame patrons, Jakob Yondok, Throbbing Wind, Christopher Nichols, Zonder Kessler, Fontaine Waite, Brainwaves to Binary, Couch, Dan Brooking, and Ian Oral, as well as our early access patrons, Ken Waite, Mason Crow, Mr. D, Jan, Liquid Egg, Alexander Prestis, Varagon Studios, Abdulaziz Hamad Alanazi, Ober, Bilguo, Alone on Mars, Code Jutsu, Ayash Sharma, Alex Friedman, Felipe Gomez dos Santos, Neil, and Danny X. If you choose to support us on Patreon, you can get early access to all of our YouTube videos, monthly alpha builds, and more.